Yeah, go on.
All right.
Hold on.
So, welcome again, TikTok youngsters out there. So we are just doing a following up on our series on parallel circuit, when loads are connected in series and also in parallel how they operate, right? So here, so we have these two display boards here, right? And we have 4 lamps here on this board connected in parallel, and in this board we have 4 lamps connected in series, right? So we're just going to go ahead now. As I said previously, I did the schematic representation of the series of the parallel circuit. So I'm just going to just further explain it, in a different manner. We're going to now go to turn on our ensure our main breaker is on. Check our voltage with our voltmeter here. Put my meter on volts, and I'm getting all right, I'm getting 110 volts there. All right, we're getting a 110 volts. All right, so go ahead now, ensure that my second breaker is on here. So I'm now just going to turn on my board. So here, so this is it now. So remember now, in a series circuit is one current and it's a voltage divider, right? As opposed to a parallel circuit, it's one voltage. However, the current in the parallel circuit is additive. So the more load is connected in a parallel circuit, the more current will be drawn from the circuit. So let's go ahead now and turn on now our parallel circuit. So this is a set of LED bulbs and light emitting diodes, and they are all in parallel. So make note now, youngster, when I unscrew one of these bulbs, right, we still have light, right? If I go ahead and unscrew another bulb, the remaining light stays on. Even one bulb leave, we still have going on, right? So unscrew again. I'm going to screw my bulb again now. Light is there, right? So remember now, a parallel circuit, one voltage. However, the current is additive. The more load is connected, the more voltage, the more power is drawn from the circuit. So let's go ahead and do a measurement here, and put my meter on amps and clamp it here and see what you have there. All right, minimum 0.5 amps flowing there, right? So that's our parallel circuit. So for now, I'm just going to turn off this switch and go over here now to my other circuit, which is our series circuit. So here we have it now. This is our series circuit. Well, all these bulbs, these lamps are connected in parallel, but they are not glowing that bright because remember now, the current, the voltage is split up between all of them, right? So we put it in 110 volt there, and each one of them would get a quarter of the total voltage apply, right? And you can apply Kirchhoff voltage law and Kirchhoff current law in this circuit, right? So here our voltage grows. So the thing with a series circuit, we're now going to unscrew one of these bulbs and see, and let's see what happens, right? So when I unscrew one of these bulbs, all the rest of the bulbs goes out, right? Right, because the circuit is not open, because right.
Just don't ask why.
Right. So I'm going to now return now. I want to screw it back on my bulb now, and there it is. All the bulbs start to glow, right? Remember now, because this is a series circuit, right? We have a voltage drop across each load, right? So you're not getting. So remember now, in a series circuit is one current. However, the voltage is split between each load, right? So if it was just this was connected in parallel, just like that over there, all the bulbs would be lit up, right, brightly. But because they're connected in series, now we have the voltage split up at the ends. You have a less glow, right? So that is it. You need just youngsters out there, try and understand a series circuit, a parallel circuit, a series parallel circuit, and their characteristic, how they operate, right? So you see, so you know that you can now move along and apply, you know, this basic understanding of circuits, right, to much more complex situations, right? So once again, here is our series circuit, right? All our lamps are connected in series, so therefore the lamp do not shine brightly because there's a voltage drop between each lamp, right? So each lamp getting, instead of each lamp getting 110 volts, they're getting approximately 22 volts thereabout, right? However, the current remains the same. One current right through. We come across here, our lamps are connected in parallel, right? And each lamp gets there's one voltage, so we have a total. We have maximum glow, right? But at the same time, right, this circuit is pulling much more current, because the more load you have in the circuit, is the more current you pull from the circuit, right? So that's it for today. So remember now to always exercise safety in whatever you're doing, and we always have a good multimeter. Test your voltage, test for voltage before you energize, and check your installation before you energize, and follow the safety protocol, and move from stage to stage and continue to study, right, and use the right material, and whatever you don't know, consult somebody who is above you, right? So that's it for today for where series and parallel circuit is concerned, and so continue to watch, subscribe, and follow us. Goodbye, right?